All right, Algebra 1A students. Welcome to part 1 of lesson 6.2. Today we're going to be solving systems of equations, two linear equations stacked on top of each other again. Today we're going to be solving them algebraically without making a graph as we did in our last video. Last video we were graphing systems of equations. In this video we are not going to be doing that. Instead we'll be solving these algebraically with a method called substitution. Okay. Now the way that the substitution method works is that we have a situation where we know what one variable is equal to in a system of equations, so we substitute what that variable is equal to into the other equation. Okay? Substitute the expression for the variable into the other equation. Here's what that looks like. Okay? We have a system of equations here that says y equals 3x and x plus y equals negative 32. What I'm going to do is, because I already know y right here, I already know that y is equal to 3x. Right? I know y is equal to 3x because my top equation tells me that. So I'm going to take 3x and I'm going to put it right there where the y is in my other equation. Okay, so then it ends up looking like this. It says x plus, and now instead of y, I'm going to put a 3x. That's equal to negative 32. I put a negative 3x because my top equation told me that's what y really is equal to, right? The y value, or the y variable, gets replaced with 3x because y and 3x are the same thing according to this top equation. Now once I have x plus 3x equals negative 32. Now this is an equation that I can solve like we've been solving for many chapters now in this book. We simply put together these like terms, x here and 3x there. That makes a total of 4x. The other side of the equal sign is still a negative 32. And now I simply divide by 4 to get rid of this coefficient. And I end up with x equal to negative 8. Okay, so x equals negative 8. And I find that just by replacing the y variable in the second equation with what I know it's equal to, and then I find that x is equal to negative 8. Okay? Now once I have that x is equal to negative 8, finding the y value, which I still have to do, I do need to find an xy coordinate point, x comma y, so I need a y value as well. I take this negative 8 and I put it right back into that original equation and solve for y, which really is just a matter of doing some multiplication, because it says y equals 3 times that negative 8 that I know x is equal to. Okay, so y is equal to 3 times negative 8, which of course equals negative 24. So now I have that x is equal to 8, and I have that y is equal to negative 24. So my final answer as a coordinate point is parentheses negative 8 comma negative 24. That is the solution to my system of equations. Okay, so once I substitute, I can solve an equation for x and then plug it back in and find my y. I have one I'd like you to try here. It doesn't matter in this case, since both of these equations are solved for y, it doesn't matter which one you substitute. I might suggest taking x minus 1 here and putting it into this top equation for y, and then rewrite that top equation with just x's, move those around and solve, then plug it back in and find your y value. Okay? So pause the video for a couple of minutes, take a look at that system of equations there. Then when you're finished, come on back and I'll show you what we should get. Okay, when we substitute, we should have this equation, x minus 1 equals 2x plus 7. Solving this equation, we end up with x equals negative 8, which is interesting because that's exactly what we had in the last problem. When x equals negative 8, I plug it right back into there to find my y value. It says y equals negative 8. Take away one more, which ends up equaling negative 9. Y equals negative 9. So I have a coordinate point, -8, comma, -9. That's my answer for that solution. That's my solution to this system of equations. All right. If you have questions about solving a system of equations using substitution, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.